Hi everyone, I hope you're enjoying the great conference. I'm going to talk about monitoring, mainly focused on what we as developers do around monitoring, not what we can, what the other people are supposed to do, the ops guys, yeah? Anybody in ops here? No? Ops? No? Yeah, one. Poor little fella. We dump the code on him and they do all the work for us. But I want to suggest that instead of doing that, we actually take ownership of monitoring in the way we develop code, in how we think about coding, and how we build our applications. Shameless plug, I work for Particular, the shirt, and I'm going to show some monitoring tools that come from N-Service Bus, that come from our platform, from Particular software. So I apologize in advance for that being the case, but that's the story. So let's start with the basics. So we all kind of been there, right? We built an app, a web app, a system that started as a small system, right? Just a couple of pages that the manager can fill in or the customer can log in and do some stuff on. And that is, was usually a kind of a monolith, a single kind of server, maybe two web servers, one, database, and all was hunky-dory, right? We kind of coded it, we FTP'd it to production, yeah? Anybody do that today? Not today, please don't. But I'm hoping in the old days, remember that was like standard practice. There was no source control or very little source control. And it was kind of, it was kind of scalable, right? It would kind of withstood the 5,000 users we had worldwide, that one of them would visit the site once a day, right? So it was okay, it ran. But what did we do after we put it in production? Nothing, right? That's just crickets, right? It's the same. We put it in production, nothing happened, right? We just put it in production, it's like... But we didn't know if, at least not me, we didn't know if it was running. When I kind of advanced into bigger organizations, there was a team around, across the thing, the ops team, that got the big, long deployment guide, yeah? I'm really old, right? So deployment guide, they put it into production, but on their system, there was some monitoring, yeah? They checked if the server's up, right? If everything's kind of, they got alerts if the server went down. They got alerts if the database went down, right? And kind of when I deployed it, I usually kind of made sure I can log in and that the database connects to the website, yeah? Yeah, familiar? No, I hope not. But that's how I lived, and that's how we lived in the kind of the old single kind of monolith, very simple code, very simple apps that lived back then. What we're looking at effectively is the ops guys were looking at, is everything alive, right? Is everything fine? And when did everything kind of, when did we kind of got really scared, or when were we called? When something went down, right? But never before that, right? So we didn't know if there was one user on the system or 1,000 users, if people were actually clicking through. That was maybe the manager or, the sales guy or the guy who was really interested in what this thing is doing, was running a report once a month or once a week or once a day and going like, hey, nothing happens. There's no business in the last while. What's wrong, right? But usually that won't really happen. So what are we actually monitoring? We're seeing that the server is running, yeah? We check that everything's running. And that's kind of like the infrastructure side of things, right? This is like, if we look at it, this is, am I alive or dead, right? The basics. Is the application processes are running, like things that we look at later, but the actual code, is it like performing what it's supposed to do? Is it serving pages? Is it rendering the thing? Can use login? All that, yeah? And the kind of the business capability side of things is like the top end. This is our, can the actual system do what it's supposed to do? Yeah, is it selling, you know, if somebody wants to buy something, is actually, you know, is it actually performing? I don't know if you know this kind of triangle thing, but this is like borrowed from the Maslow hierarchy of needs. Anybody know that idea? Okay, so basically the concept is that at the bottom is like what we need to live, air, water, you know, food, money. The second level is what we need to kind of live well, and the top level is like, you know, utopia. You know, it's like we're there, right? We have a meaning to life and all that, right? And the same here, we're trying to borrow this kind of concept where, you know, you have to have the infrastructure running in order for the application to execute, and then to actually do the business that you meant to do. You could argue that all this should be the other way around, right? We are developers, I know, we think about technology, but you know, if the business doesn't run, none of this exists anyway, yeah? Just a thought. So we look at our different capabilities, and this kind of gives us the a thinking, but it's really only one aspect of monitoring, isn't it? This kind of says, you know, do we have everything running? Is my application actually working? Is it performant a little bit and all that? And then the business capabilities is like, yeah, is there like, can users access the system? Do we meet their SLAs? For example, you know, if we need to render a catalog page, does it render, you know, so people actually can see it, or does it take, you know, 20 seconds to render? And what's the impact of adding more customers on the platform? For example, you know, having you know, running an ad campaign, and the slow, sluggish website that kind of made it when we had 5 users now has 1,500 users. Will that, you know, will that be my Black Friday red in the trenches and the war room to kind of make this thing work somehow? Yeah. So we can think at this pyramid being a 3D, 3D. And the first aspect that we looked at is like the monitoring. So monitoring area, the infrastructure, the application, the business capability. The other aspect, another aspect would be the monitoring concern. Health is one of them for, you know, performance and capacity. So performance would be, you know, do we deliver everything fast enough? And capacity is more around, you know, can we do better in the future? Will we be able to sustain Black Friday? And we can add another monitoring aspect to that, and that is passive, active, reactive, and proactive. So passive is like me sitting, like in the good old days, I'm sitting there. If the phone doesn't ring, if nobody hits me on the head, I'm all right, yeah? You know, everything's fine. Reactive is like, yeah, I have this email coming in when the CPU is at 90%, and my disk space is at 90%, and you know, the network bandwidth is just about to crack, and my users begin to pick up the phone, okay? So they haven't called yet, but I get a sense of doom coming just a minute before it's going to come, right? And proactive is like, I can see the monitors as I work every day, and I can tell that something's going on. In today's DevOps world, yeah, I deployed a new thing to production just an hour ago, yeah, I coded, I committed it, I pushed it, it went through testing, everything went into production. Anybody does that today? Continuous delivery, yeah? It's nice, no? It's also very scary. So if you don't have monitoring in that scenario, you're cooked, yeah? You're like, you have to look at the board all the time to make sure that everything's fine, and if everything is not fine, you should be able to react quickly. In this scenario, in the proactive kind of scenario, we do that all the time. This is our process. This is the way we live, right? And that means that users rarely, unless it's really like a proper outage, users will not know that anything happened. We usually will be able to fix this kind of issue really quickly and fix it, and the users will not even know that we were there. So to summarize this kind of monitoring aspects concept, just to give you an overview, we're looking at the area, we're looking at the concern and the interaction type. If we kind of look at it as in a holistic way, we can it becomes very interesting, because now it's not only if things are running, it's not only if the application is running, it's not only the business thing, it's like everything needs to kind of work together, and we need to take care of all those scenarios. So let me talk a little bit about the kind of the top end, yeah, the where we want to be. Once we sorted out all the infrastructure stuff, so we built our code, we built our servers, and today it's really simple, right? We just do another VM, that's old. Another app service, or the parallel in Amazon, or a function or whatever, deployed to that kind of auto enables itself. It's there. It's all taken care of, right? Today, who does on-site today? Like not cloud. Cloud? So most of the room is doing cloud, right? So we're all, this bit, the bottom one is like not our problem, right? We're back to the old days. The application layer is our problem, and the business layer is definitely our problem, right? So let's think about what can we do to get our monitoring better. Let's say that we have like a dashboard, yeah, in our development thing, where we see the builds, are they green or red and all that. Do you know that one? Yeah, you have that, I hope. So you should know that, things are breaking or not. At the same way, we would have the production monitors and the UAT monitors that show us the behavior of our application, yeah? The actual business thing that's running in our software. And we look at the numbers of how many orders, for each order that comes in, how many emails are going to be sent, for example, or how many credit card charges, shipping acknowledgements, all kind of, business data, the actual business process, yeah? If we collect this data as we build our application, we will know immediately that something is going wrong, right? If we have a Black Friday and the number of orders suddenly dropped from 1,000 a minute to 100 or 10 or 0, then something's wrong, right? We don't need to be, all we need to look at is who done the last check, who kind of committed the last change, right? And maybe roll it back, or maybe something horrible, really, networks went down or something. The same for another example is like our checkout process funnel, yeah? So how many people start the checkout process, then, some of them usually drop, somebody would love this iPhone, he really, really wants to buy it, and he goes through the whole checkout, and then he comes to type the credit card details, and he starts shaking. You know that feeling? Yeah. Okay, so, so some of them will drop, right? Not all of them, but we have an average. If we track it through time, we have the performance of the system from business perspective. We collect the data, we know what's going on, then it's really useful to know all these details and allow us to have the ability to tell that something went wrong, yeah, that something is critically wrong and we need to take care of it, okay? I know we're not thinking about business, yeah, but don't forget it. They pay our wages. They let us build amazing things, right? And do all this, use all this technology, and do all this, the fun that we're doing. So, business is where everything lies. The other aspect that I want to just remind you is all about performance in the application layer, about performance and performance intelligence and information that you can get from your code as it's running to say whether it's performant or not. Anybody does like tracing? Do you use Azure? Anyone use Azure here? Application Insights, yeah? Do you use Application Insights? If you hook in from your code to Application Insights, what do you get? Loads of data. Just a tip. So again, you know, you can get this data, you can display it on your dashboards, collect it, have this kind of information running as part of your process, as part of your everyday life. And that will help you build a better picture and be a lot more ready for when things go bad. You know where to find the problem and fix it. It's very easy because you have all those metrics to support it. So coming back to our nice happy world of having the monolith, we built this thing, and the business went, it's going well. There's more business, there's more requirements. Business start building up, and they say, listen, this is not performing, right? So what do we usually do? Definitely today, we go microservices, right? But before we go microservices, we start distributing our app, right? We start taking some bits out that are really handy to do in an asynchronous fashion, like sending emails or converting PDFs or integrating with the CRM. And we build endpoints and put an insertion point in here in the business layer, start sending messages out, and now we've moved from a very comfortable, very visible kind of one thing either works or doesn't work to a distributed system, right? We have all these, now we have more things deployed with the application. We obviously have a lot better performance, and things are we're able to scale a lot better. We get durable messaging as a benefit from that, because now we just pack in send a message, and we don't need to worry about it. It will deliver, but we add some complexity here. Now, instead of monitoring one machine, now we have maybe multiple machines, or at least multiple processes, each having their own thing, right? So, from here we will probably go to microservices, right? To deploying multiple components with their own database over the network, different types, maybe stuff running on Linux, stuff running on Windows, stuff in the cloud, maybe a collection of these. And now we need to really, our monitoring becomes a much bigger problem. Yeah, agree? Anyone there yet? So what we want to do is to get a better sense of what's actually happening, okay? So we have multiple processes, and we obviously have messages running now. Some kind of messaging, if we're doing distributed, we are hopefully doing messaging. Anybody does here kind of RESTful microservices? RESTful as in, one microservice talk to another over REST? Come see me afterwards. Come see me afterwards. Please don't do it. So hopefully you haven't done that, and you're going with proper distribution using messaging, and that introduces the added layer here, or the added dimension here of messaging. Messaging is very different to RPC. It doesn't do request response. It doesn't explode. It's very durable. So, you know, those systems, the proper distributed systems, if they're built correctly, they will be durable. They can run forever and do zero work. Yeah? They will not explode. They will not show on the monitors as doing anything wrong. Everything's fine. Their CPU is fine. Their disk is fine. They're totally there, but they're doing nothing. And therefore, we need to introduce some kind of message queuing monitoring in addition to what we talked about earlier. So it's something, this one is, again, shameless plug, Particulars platform, but very similar you can find in RabbitMQ, Azure Service Bus queues, and the likes. They will all have something like that, yeah? Something that talks about how many messages do I have in a queue, how they're performing, anything stuck, anything problematic. I could see that, and I could usually plug in some alerting on top of that to know that something went wrong. So let's look what would interest us with messaging. So first of all, the flow is like I get messages into the queue. So I want to know if I have a lot of messages in the queue or little messages in the queue. What does it mean when I have a lot of messages in the queue? The process is stuck, yeah? Something is not happening there, right? Or it's not running fast enough, right? I can't consume enough messages to keep the queue empty. Does that make sense? So that's my entry point, yeah? Then there's another, so now we are pulling messages off the queue. We're looking at the throughput, yeah? So logically, how many messages can I process off the queue in a given time, yeah? How many? So 100 messages a second, 1,000 messages a second, 3,000 messages a second. And then there's another interesting one, which is the number of retries, yeah? So how many messages, how many times have the message been pulled off the queue? We try to process it, but something went wrong, it goes back to the queue. Have you, anybody does retries in his code? Yeah? A lot of hands, that's very good. So that is a failure condition that we want to know about, right? Because maybe something in our code is wrong, or maybe there is congestion, or maybe just a simple race condition we can do nothing about, or maybe there is something we can do about it. So that is an interesting parameter. And the last one is the critical, sorry, not the last one. Next one is the actual processing time. So I've taken the message from the queue successfully, and now I'm processing it and taking it off the queue completely, yeah? So I'm peaking, doing the processing and taking it off the queue. That's the time that actually it spends in the handler, yeah? So the time it takes me to open, deserialize the message, look at it, go, oh, I need to do this, you know, call the database, update some things, send another message, end of transaction. That is the processing time. That's the time it's actually spent in our code. The next one is critical time, and that is like the overall, it's the envelope, yeah? It's the time it took from the time that the original message arrived in the queue to the time that it actually was processed. So if I have 100,000 messages in the queue, would that make a difference to my critical time or not? Yes, correct. So it is the time that the whole process takes. It's the whole envelope, yeah? So that gives me a sense of how well everything is going. If my critical time is constantly going up, what's going to happen? Something bad is going to happen, right? So I will end up in a position where, you know, either my disk will run, you know, where I store my messages, I'm going to run out of quota or something like that, or maybe something similar, but something is going slow and doesn't get any better. It's not like fluctuations or something like that. It's constantly going up. If my critical time is going up, I'm in a bed, I need to raise the alarm, go into the war room and start thinking what I'm doing now, yeah? When we look at this kind of monitoring system, it's interesting to look at the type of messages that are there, yeah? And see which messages are taking how long, and why, and can I do something about it, maybe to make the performance better, or maybe make the important messages process faster. So an example would be if I'm charging a credit card asynchronously, for example, then I want to make sure that this type of message is flowing through the system really quick, yeah? That I don't have performance issues here, that it's not waiting in the queue. An example would be, I don't know, my $1 million order, okay? So I have an ordering system, and I have commercial clients, so big, Microsoft and Intel and all these that are buying. Each purchase order is like, what, 1 million, 2 million, and so on. And I have my regular customers that I like very much, but they pay, per transaction, they pay an average of $10, right? So I have those two types, right? What should I do with the $1 million orders, do you think? For example, put them in a separate queue, yeah? So if I have them both on the same queue, on the same endpoint, which is okay logically when there's no pressure, right? Then it will work, right? But if I have pressure and I have those $1 million orders delayed, and the customer doesn't get a reply on time, and that doesn't look very good, yeah? And then he'll cancel the $1 million order. It's going to be very painful. So for an example would go, I look at the monitoring system. I see that I'm handling 10 message types or 100 message types in this endpoint. Maybe it's a good idea to move that message over to its own endpoint, that message type to its own endpoint, and then have a separate process processing it. It will be faster. It will be easier to troubleshoot, and we'll get a better SLA and all that. So that kind of leads into the last point, which is queue load distribution. Again, something that you wouldn't think about until you have problems with queues, and you open your whatever queuing system it is and go, I've got 150,000 messages in the queue. That's nice. What's the problem? Now I need to, anybody did that with MSMQ, for example? One? Good. I feel for you. In MSMQ, it's horrific, yeah? It's like almost the most oblique thing you can find. It's a great system. It's old. It's bulletproof. It's all there's a lot of good things about it, but it's really, really hard to debug what's going on. So you always end up building something on top of it to kind of figure out what's going on. So, sorry? So I'm going to give you a quick demo, just to kind of give a sense of kind of monitoring in the context of messaging. We're going to look at a very, it's a demo, okay? It's a simple system. We have this client UI sending messages to place an order on the sales endpoint. We then go from the sales endpoint publishes an event, order placed, and the two endpoints, billing and shipping, which you can imagine what each one does. Yeah, the billing would take care of the charge, the shipping would take care of shipping. And once the billing is done, then the billing is going to publish an event that order is billed, and then the shipping endpoint will know that it could actually ship, right? So it prepared everything, and now it can actually ship. That's the scenario. It's pretty simple. It's pretty basic. You can go to this URL here. I think we distribute the slides, don't we? Or we do, yeah. So you can go to that link over here and do it yourself. You can see, I'm going to share my screen now and show you what I'm doing to run the demo. It's exactly what you can do. It's like, it's a self-destructive thing, so it doesn't leave any traces on your machine, it's very simple, but it gives you a good insight to how messaging monitoring looks like. So if you downloaded the solution or the zip from that link from the website, you just need to run the bat file, run.bat, and I'm going to use local DB here. Basically what it's doing is kind of deploying a simple system that has a couple of endpoints. It also deploys the platform, which is service control and service pulse. And that allows that will run, and those endpoints, I'll show you why once it's getting ready. It got ready. So we have our client UI that sends the messages. We have sales, shipping, and billing. And each of them has a little bit of a tweak in it, so you can play with stuff, yeah? So you can add some load, make it work slower, faster, and so on. And here is our monitoring system. This is part of the platform. This is called Service Pulse. Behind it is Service Control, which is like a console type of thing. Yeah, it listens to all the messages, it consumes them, it builds the data on top of it, and publishes events if things happen, when things happen. And we use Service Pulse to using a REST API to communicate with Service Control and display the data to you. So you can see there's a dashboard. I have four failed messages here, probably because I did something wrong. We have some, we are able to see which endpoints are running. We can see our failed messages. Something happened. Let me see what happened. Something went wrong here. I have the stack trace. I can retry the message. I can archive it, and so on. Yeah. We have some custom checks and configuration. If you want to play around, please feel free to do that. So here we have the four endpoints. So the billing, client UI, the custom check monitor third party, it plays as a RESTful thing. Sales and shipping. What's important to notice here is that like client UI and the third party, as you can see, they're processing 0 messages. Can you think why? Exactly, they're sending, okay? So these will always show flat, there's nothing there, okay? The rest are consuming our processing endpoints, and they will go through that. So here we go. So the queue length, this is how many messages we have in this in our queue. We have the throughput, so what is my average message per second. We have our retry rate. At the moment, there's no retries. I'll make it do retries. The processing time, so that's the actual time it's spent in the queue, not in the queue, sorry, in the handler itself, in the code, and the critical time. And if you look at what we see right now, when the system is running quietly, it looks okay, right? Doesn't look frightening. Everything's fine. Whatever is, the average processing time is not great. Maybe a second and a half, but it's all right. So let's try and make it worse. So here we are going to introduce some failures, okay? So, and I'm going to give it like 40% failures, yeah? So this is a scenario where, we're trying to update the database or make a call to somewhere, and I get an exception. The message will end up back in the queue, and I will retry again and again and again. There is a whole thing. At the end, when the retry fails totally, it will end up in the error queue, as you see there in billing. Yeah. So when I created failures here, yeah, on the billing endpoint, we saw that it's going up, and the processing time, the critical time, also goes up dramatically, right? Which makes sense, right? Now let's do let's make the Black Friday, small version of Black Friday. Instead of 1 orders a second, I'm going to get 8, which is a significant increase in our story. And we can see that if you follow my mouse, that sales is beginning to go up, yeah. So I now have 68 messages in the queue, which is going to grow up to 94, and so on and so forth. We can see that everything starts looking not so nice, yeah? And now let's add some pepper here. I'll now decrease the time that it takes to, I make it longer for the messages to be processed, yeah? 2 seconds for each order. So now sales not only has a lot of messages in the incoming queue, it also has its processing time is going skyrocketing, yeah, and the overall critical time is going very, very, so that endpoint is going to die, right? It's not going to die, right? It's not RPC. It's going to just become a bottleneck very quickly. So another thing we can look at now is to see what's going on, yeah? And here, in this scenario, we only have one message, so there's not a lot to do, because there's only one message being handled, and I guess the only thing to do is to look into the code and see why it's so slow, right? But for another example would be, I think in billing, no, it's also 1. Probably shipping, yeah. So in shipping, for example, we have 2 messages. One is a handler that handles 2 events. One is order placed and the other is order build. And let's say that one of them was like very slow. We could think about taking it out and distributing it to another endpoint or something like that, yeah? We can also see multiple instances here, by the way, yeah? So we can see, like, if we're distributing the same type over a web farm or something, then we have like 10 instances or something like that. We could see each and every one of them. All right. I'll stop this before my CPU burns. Okay. So I hope that was useful for you. So I'm going to tell you. So I'm going to tell you a little bit of trench war stories. I'm not that old, it's okay. This is from, I think, the First World War. Canadians took Hill 8 or something like that, stole it, but it's, well, I was supposed to inspire you or whatever. So I'll tell you a little story from about 5 years ago, maybe a little bit more. We built this system. The system was not huge. It only had like 800 servers or so. There were like, it was geographically distributed. We had like multiple countries using that system in different contexts. We had a lot of pressure, so it was a system that was creating 70,000 euro or pounds an hour, something like that, yeah? Making, not the cost and the money that went through, yeah? It was the profit was 70,000 euro an hour. And it was to do with money, so it was very, as you can imagine, right? It's not nice when money goes out the window. They don't mind about other things, but money, it's really important. And we had, you know, a significant, it was a significant operation. You know, we had like 300 developers. The rooms that, you know, each room of this size, most of the walls were all monitors, yeah? So, as what I spoke about earlier, and that was before all those lovely tools. So we had to build all these kind of monitoring tools with MSMQ, and that was fun. But we had monitors everywhere, all over the world, for every environment, for every business profit center that had its own dashboards, and we could see everything about everything. And we kind of, you know, kind of casually, the sales guys came to us, you know, 2 or 3 weeks ago, and they said, oh, you know, like we're running this thing in South Africa. It's like a little ad campaign, a little bit of video. It's not going to be a big deal, but, you know, do you think you can handle, you know, 10, 20% more, just to be safe, you know? And, you know, we checked our monitors, we checked our capacity planning thing, and I was pretty confident that that was okay. And I said, yeah, go ahead, there's no problem. And we came to work the day after they published it. Actually, I ran to work at 3 o'clock in the morning, yeah? It was like everything went red. You know, PagerDuty was like on me. I was one of I was on call that night, and we came in, everything was red, yeah? But everything, like it was not nice, yeah? The benefit was that we had all this monitoring, we had the statistics, we knew where to look as immediately as things started. So I came in, I couldn't touch the code. The guys came in at 7 o'clock in the morning, 8 o'clock, because they were paged, and we started looking at how to fix this thing. And because we had the monitoring, because it was all distributed into queues and all that, we were able to look at it and go, oh, these are the endpoints that fail. They were not failing like failing, they were just piling up, yeah? And everything was like, you know, we're beginning to look at the possible problem with our disk space, yeah? So increased disk spaces, we increased memory on whatever we could. We moved some endpoints from one machine to another. We were juggling, basically, for a couple, you know, to buy us some time. But then we were able to look at the critical messages that were piling up, pick them up, you know, refactor that slowly. So it did take 2 weeks. It wasn't a day, right? And we did have to struggle and do a lot of magic to make it work for a couple more days. But we did resolve it after 2 weeks, right? And after 2 weeks, this is like the system going from like, it's 300% capacity, yeah, in overnight, right? So in a monolith, how long would that take you to do? In a regular system? Suggestions, please. A week? Who said a week? I'm going to buy you a bottle of whiskey. And I'll get you to come work for me as well. So from my experience, I've been doing this for 20 years, 20 odd years. It's going to take you anything from a month to 6 months to fix something like that, yeah? You're talking about, you know, thousands and thousands and thousands of transactions a second, yeah? You're talking about database changes, code changes. I don't know, where would you get capacity from, but you will need to do a long, long bit of work and then stabilize the system. And this is a monolith I'm talking about, yeah, not a distributed system, yeah? But because it was distributed, because it was messaging, because we had the monitoring, mostly because we had the monitoring, we were able to recover from it and quickly understand where the problems are and quickly fix them, yeah? Where we didn't need to scratch our heads, it was showing up. It said exactly where things were breaking, yeah? So I hope that was inspiring. Turn the lights on. Anybody here likes to drive 120 kilometers an hour in a dark night without the lights on? Join me as I go for suicide. No? Nobody. So please turn the lights on. Doesn't make sense to drive 100 kilometers or 1,000 kilometers an hour as we drive with our systems and go like, well, I don't care. If there's a wall there, I'll meet it. I don't know, maybe. And remember that distributed systems are durable and that you won't know until it's going to be really bad, yeah? Not just a little bad. It's going to be really, really bad if you're not monitoring. And remember to look at all the aspects of monitoring, yeah? So the area, whether you're looking at infrastructure, application, or business, the concern, health, performance, or capacity, and the interaction type, again, whether it's reactive, passive, or proactive. Any quick questions, because I'm 5 minutes over time. Anyway, you can come over. If there's any questions, you can come after. Find me around here. Thank you very much for your attention.